If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in basic level where we are discussing the concepts on vectors. So today we'll see what do you mean by position vector, some vector additions formula, multiplication, and then some triangular inequality or equality, then finally section formula. Okay, then let's see this. Now what is position vector? Now in vector you will listen, or sometime you will say vector, sometime you will say position vector. Vector is general, any vector. If I say this is a vector, okay, from A to B it is going vector. But if I say it is a position vector, then it is fixed. One point, initial point is 0. And then this is suppose A. So this is OA vector, always fixed. If I say position vector A, that means O is not written here. So you will, by default you say it is OA vector. Okay, that means it is starting from origin, it is reaching at A. So position vector is nothing but your coordinate. In coordinate geometry, what we say coordinate, position vector is same as unit vector. If I say position vector of the point A is 2i plus 3j, that means from origin this OA vector is 2i plus 3j. That means the coordinate of A is 2, 3. So whatever coordinate you learned in coordinate geometry of a point is same as position vector in vector. So in vector it is nothing but coordinate of that particular point. So position vector P of a vector with respect to origin, that is OP vector. It is always with respect to origin. This is fixed. With a given origin, each point has a unique position vector. Suppose this origin is given, obviously each point will be having different coordinates. This point has a different coordinate, this has a different coordinate. So all position vectors are unique because this has a unique coordinate. This coordinate and this coordinate will never match if this is fixed. If you have given origin, then the coordinates of each point is different. So that is the concept of position vector. Don't get confused by position vector and vector. Now if you come to vector addition, there are a number of ways we can add vectors. If two vectors A and B are represented by suppose I am talking about now position vectors. It is OA vector, it is OB vector. So this is named as A vector, small a. This is named as B vector. Then what will be their sum? So I told you can shift any vector anytime. So if I shift this vector here, this is shifted here, then you draw a parallelogram, or you draw a parallelogram using two vectors. So that is known as parallelogram. This diagonal is give you A plus B vector. You remember your complex number? It was Z1, it was Z2, it was representing Z1 plus Z2. Same here. It is A vector, it is B vector, so this will represent A plus B vector. So that is representing A plus B vector, this diagonal, which is known as parallelogram law. So suppose another vector, the another one I have given. Suppose this vector, you know this vector. So what will be summation of this vector? You draw a parallelogram using these two as adjacent side. This diagonal will be another vector. So at any time, suppose you have given a vector this, you have given another vector this. So you need to find what will be the summation of this vector. I don't know, any vector you can give name. So you draw a parallelogram using these two, draw this. So this is the sum of these two. Suppose this is A vector, this is B vector. It can be position vector, it can be any vector. So it will be A plus B vector will be this one. Suppose this is C vector. It can be A to B, A to C, whatever initial coordinate. It can be position vector, it can be normal. So it is known as parallelogram law or parallelogram law, using parallelogram. Now in vector addition, there are other addition rules also, we will see. A plus B vector is B plus C vector. Vector is cumulative, either you commutative, either you add A or first or B first. It is also associative, A plus B. Associative means you can form association with AB or you can form association with BC. Ultimately you are adding the three, meaning is same. A plus null vector is A minus A vector is null vector. Okay, that is zero vector. Distributive is not possible, it is not something of that vector. A vector plus B plus C, you cannot distribute it. A into B plus A into C. No, you cannot do this one, which was known as distribution property. It is not possible in addition, in vectors. Multiplication of a vector by a scalar, already we have seen. If you multiply by a scalar, only the direction remains same, only the magnitude. Instead of going 20 km, now you go 40 km in the same direction. So if A is a vector, M is a scalar, then MA is a vector parallel to A, that is same direction, whose modulus or magnitude is M times that of A, mod of M times of that of A. Why I am giving mod of A? Because M can be negative also. So if you multiply by minus 2, so it will go 20 km. Suppose it was going 20 km in this direction. So if you multiply it by minus 2, it will be parallel to that one, then it will go opposite direction, that is minus 2. It can go either same or opposite. So positive, it will go same direction. If you multiply by negative number, then it will go opposite direction. So minus 2 will give you 40 kilometer in reverse direction. So that is 2 times of that 20 kilometer, 40 kilometer it is going, but in reverse direction. That's why mod f is given. So they are parallel, because parallel doesn't mean it should go in same direction. It can be like, it can be dislike parallel, but the segment should be parallel. Directed segment, line segment. This is known as scalar multiplication. So this is a into m or m into a, all meaning is same, m and a. So you can multiply m and then a. M plus n, you can distribute it because it is scalar, ma plus na. Ultimately it will either you go directly 70 kilometer or you go first 30 kilometer, then take some rest, then again go you 40 kilometer. Ultimately you will going 70 kilometer in that direction. M into a plus b. So you need to go 20 kilometer this, you need to go 40 kilometer this. 2 times this direction, 2 times this direction. So you go 2 times this direction, or you go 2 times. You add both this direction, then you go 20, or you go 2 times there, 2 times there, then also you go. That means if the point is suppose P, suppose you want to go at this point P, whose coordinate was 2 plus 3i. So you just want to multiply 2 times. You go double in this direction. So you multiply 2 times, so it will be 4 plus 6j. 4i plus 6j. So either you directly multiply P OP by 2, so 2 to 4, then 2 plus 3, 6, or you go 4 unit there, 3 unit. You multiply this 2 by into 2 and this 3 into 3. So you can see either you direct multiply 2 into 2, 4 plus 3, 6i, or you 2 into 2, 4i, or 3 into 2, 6i. Add it. That is different. Now vector addition, there is another concept of continued addition. Suppose you have 3 vectors A, B, C. You want to add this vector. So I told you vectors you can easily move. So this was a vector, then you bring this B, this initial point you bring it to the destination final point of A. Just one after another you put it. So B will be coming here. So I given dotted line. So this B I have shifted from this to here. It should be parallel, just sliding from here to here. Direction should not change, magnitude should not change. So it should come here. Then from that initial final point you start that C initial point. You can bring first C, then B, no issue. Anyone you can bring first. That is on your choice. Next, if you bring C, finally if you add this is the final point and this was the initial point, and finally you got to reach here. So if you draw this line, that becomes the resultant of these 3a plus b plus c. You can see here, you go first 2i there, then you go 3j here. So if you add, this was the initial point from where you started, you add this point, this is your OP vector. This is 2i plus 3j vector. This plus this will give you here. So summation of all 3. Now what is triangle law of addition? You have already seen in complex number. This is A, this is B, then this represents A plus B, and this represents A minus B. How it will coming? This is also triangle law of addition, from where this will come. That is also another law. Suppose you have this line A vector, you have this one B. So you need to find C. You form a triangle using these two. So that these two are in same direction. It should continue one direction. So you shift this B here. So you are moving in this direction, then same. Then you stop. Whatever you just now you have done, continued fraction. So this plus this. So you can see two sides are in same direction. You can see it is going in clockwise. Suppose if I say this, and the resultant is just opposite to this one. So you close a triangle with the opposite direction of the other two. Other two was moving in this direction. So with this direction it should come in this direction, but the resultant will be just opposite to that. So summation of these two. So now if you have A vector and V vector, if you want to have A minus B, what direction it should have? It will have this direction. How? A minus B. Because if you say this is continued, you see continuity in the direction. So you see you start from here B, then you start from, this is the continuity you can have. From here you are going here, then you are coming here, and this is just opposite. So this is the resultant of this plus this. So if we add this plus this, you can see B get cancelled, you will get A. So that's why this will represent A minus B. Similar to your Z1 minus Z2, what you have done in complex number. It's the same idea. So if you have two vectors, you will see, suppose you have two vectors. Suppose now you have a vector, position vector. Suppose A is the position vector, B is this position vector. What will be a minus b, this one will be a minus b vector, because this is b vector, this will be a minus b. You can see continuity, b plus a minus b should be equal to this. So b will get cancelled, will get a. So as at any time you can now find any vector. 2 points are given, initial and final points. Suppose initial position vector, final position vector are given. You need to find this vector. This is initial, this is final. So final minus initial is your answer. That vector, this vector. So that is known as triangular law. So now what is triangular inequality? You know, say the third side, magnitude of third side of any side is greater than the sum of other two sides. So this is this triangle. If you say this sum of two sides is greater than the third side, and difference of two sides. Now if you take the smaller one, difference of two sides is always less than the third side, this side. So these two are known as triangular inequality, which is applicable in complex number also, in vector also. So you will find quite a resemblance between these two. Now what is section formula? Now whatever you have done in coordinate geometry, that will be replicated in vector. Why? Because in coordinate geometry, whatever the point was the coordinate, here it will be in position vector. So you can say the position vector, point A is A vector, position vector of B is B vector. In coordinate we have written it in under bracket FCC and ordinate format. And suppose C is a point which divides AB in the ratio m is to n. And what was the formula? M into B coordinate, that is m into, in complex it was z2 plus n into z1, but here also same. So m into this coordinate is now position vector is B vector. Instead of 2, 3 it is written as B vector. B vector represents this position. So m into B plus n into A divided by m plus n. If it is internal, if it is external, then minus. So position vector of midpoint of AB, what will be the midpoint of AB? It is A plus B by 2. So all the formula what you have learned in coordinate geometry and complex number, you will get quite a resemblance with your vectors. If you like the video, then press the like button and please give your valuable comments in the comment section.